Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2011 Calculus BC exam, question number 3 from the non-calculator portion. The problem reads, let f of x equal e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axis, and the vertical line x equals k, where k is greater than 0. The region R is shown in the figure above. It says, in part A, write but do not evaluate an expression that involves an integral that gives the perimeter of R in terms of k. Now, if you watched the Baker's Cake episode before this one, then you'll see this to be a very familiar question. If not, that's okay. The perimeter is going to be this piece right here. Perimeter of any shape is always just the amount of space it takes on the outsides. So it's going to be this arc, this straight line, and this horizontal straight line as well. So let's do the easy part first. Let's do the horizontal straight lines. Well, the first one on the left here, right here is 1. Plus, the horizontal straight line here is a distance of k. And then the second vertical straight line is going to be e to the 2k. So that takes care of my 3 sides. And then, to find the fourth side, I'm going to integrate from 0 to k of the arc length. So that's going to be 1 plus, we got to figure out what the derivative is, f prime of x. Well, let's write it out on the side right here. F prime of x, well, f of x is e to the 2x, so that's going to be 2e to the 2x. So that's what's going to pop into here. And that's going to get squared, slap on a dx, and that's as far as you need to go for part A. Pretty straightforward in terms of questioning at the beginning. Let's see, hopefully it doesn't get much harder, but if it is, we will be ready for it. The region R is rotated about the x-axis to form a solid. Find the volume of V in terms of K. So if we rotate this thing about the x-axis, it's going to be a dx integral that is solid. So the good thing is we don't have to worry about any kind of like top minus bottom or outer minus inner because it's a solid figure. So I can go ahead and call him pi times the integral from 0 to k of e to the 2k, or 2x rather, squared dx. Before I integrate, I'm going to simplify, so that's going to be pi equals pi times the integral from 0 to k, e to the 4k dx. I keep doing that. Darn it, it's not e to the 4k. You know what it is? I keep thinking about sequences in series. I think that's why I keep putting k's in to those exponents. And so what I'm going to get here is I'm going to get 1/4 because of rule chain on the integral of e to the 4x. It'll be e to the 4x, but then there's this pi hanging out on the outside here, and that's going to get evaluated on 0 to k. And now from here, the pi over 4, I'm going to kick him out, and what I'm going to evaluate is e to the 4k minus e to the 0. And that right there is what gives me my volume of that shape. Okay, let's see if we have enough space here for part C. We might have enough space for part C. It says in part C, the volume V found in part B changes as k changes. So they're telling us dk over dt is equal to 1/3, and they want dv over dt when k equals 1/2. Well, this is a classic related rate problem. And so when it comes to related rates, it's always the same pattern. They give you the rate that they give you, and then they want the rate that they want from you. And what your job is to find a relationship that establishes and relates all these things together. Well, it actually said the volume found in part B, so they're giving you a clue. They're telling you that that is the relationship you're going to use to link up V and K, which is this formula that you just found in part B. So before I do anything to that formula, I'm going to, or rather before I do any calculus to it, I'm going to go ahead, and I guess I'll just do it in this color. I'm going to simplify him out a little bit. So I'm going to call him e to the 4k minus 1. And then that's going to give to me, and I think I might be overestimating how much space I have again, pi over 4 e to the 4k minus pi over 4. And now from here, I will go ahead and take the derivative with respect to time on either side. And that will give me my related rate formula. So dv over dt, which is what I'm solving for, is equal to, kick out the constant, pi over 4 e to the 4k times 4, and then dk over dt. Now this constant's derivative will just go away. The 4 came out because of chain rule of this 4. The k's derivative is dk over dt. Well, the 4's are going to cancel each other out, which is good. dv over dt is going to be pi e to the 4, not k anymore, but 1/2, because k equals 1/2, and then times 1/3. And at that point, you can kind of just leave it as is, but if you really wanted to just clean him up, you could call him 2 here, so pi e squared over 3. And that will wrap it up for that problem. Okay, I think this just about wraps it up for this mini series of FRQs. As always, please leave comments and questions in the comments area, and I will see you all next week for some more FRQs. Keep practicing, keep training hard, stay healthy, and we will see you next time.